Welcome to the Introduction to Periodic Functions. I'm going to do trig for several weeks, and I wanted to give you the basics right off the bat. And we're going to talk about how to graph a periodic function, and we're going to talk about amplitude, frequency, period, and midline. So the first thing I want to show you is a periodic function. A periodic function is a function if its values repeat at regular intervals. Another way to say this is if the graph is shifted horizontally c units, the new graph is identical to the original. So basically, we learned that if we shift horizontally to the right or left, that is an inside change. We just learned that in our transformation unit we just did. And it's going to shift it to the right or left along the x-axis. So it is a change in your x's. So if you were to look at this first one right here, I've got a couple periodic functions. It looks like a triangle. If I were to shift this way, how far would I have to shift it over so this first triangle is going to be on top of this one? So if I had f of t for this one equals f of t plus c, because I'm going to shift it to the right, if I shift it to the right, it's going to be actually t minus c. So if I were actually going to shift that, I would have to shift it 1, 2, 3, 4. So really, this f of t is going to equal, if I took and did this, if I shifted it to the right 4, it would be right on top. Okay, and it keeps repeating and repeating. This one is another periodic function. See how it's repeating. So if I look at this one, if I was going to shift it, it looks like if I shift it 1, 2, 3, this one's 3, it's going to repeat again. So again, that's going to be a shift to the right. So the period of this one right here looks like, how long does it take me to see this one? Oh, it takes me 4 to see this one, the period on this one. If I shift this one, how long does it take me to see the whole thing? Well, the period of this one is 3. So these are periodic functions. They are not trig functions, but a way to look at something that repeats. So it repeats at regular intervals. Okay, so let's look at the definitions that we need to know so that we can go through and do these. So things we learned with trig functions are amplitude, frequency, period, and midline. And these should sound familiar to you because I know we talked about it last year, but we're going to go through and review it. So first of all, the amplitude is how high, the question is how high or low do you go? That's the question what you ask when you do amplitude. So if we were actually going to figure out what that is, the amplitude really is the vertical distance between your max and min of your graph. Okay? And the formula that I'm going to have you use to do this, you either going to take your high minus your midline, and we'll talk about what midline is, or you can take your midline and subtract your low. That will tell you what your amplitude is. And your amplitude is always positive. So this was always, so you have to remember this. Amplitude, usually you will see an absolute value because it's always positive. It's never negative. So you can't say you have a negative amplitude. Amplitude is just the distance, your vertical distance between your max and min of your graph. Okay? So, frequency. Okay? How many do you see? That's the question you ask, is how many do you see? So that's your frequency. Okay? And your period is how long does it take to see one complete curve? That's the question that a period is. So period equals 2 pi over your frequency. I will let you write it as P equals 2 pi over F. So that is your formula for that. So these are tied in to each other. If you know the frequency, you can figure out the period. If I know the period, I can figure out the frequency. So these are tied in together, okay? Midline is your high plus your low, or your min or your max, divided by 2. So it is called a middle line. Sorry, midline, I made it. It's your middle line, and it's kind of like an average. So if I'm looking for the midline, it's always going to be a y equals a number of some sort, but it's like an average. I'm going to take my high and low, and I'm going to find the midway. Now, there's a method to my madness. There's a reason why it's stacked this way, because when you look at a formula of a trigonometric function, the amplitude comes first, the frequency comes second in your formula, the period is only on your graph. So the amplitude is in your formula, that's F for your formula, your frequency is in your formula, and your midline's in your formula. The period is only on your graph, so that doesn't show in your formula. And typically you're going to do this in a different method, and I'll show you an example for the next slide how I want you to do this when you look at this example. So let's look at a graph, and I can tell you what we do. So here I've got amplitude, frequency, period, midline, and I have this beautiful periodic function that's repeating, repeating, and repeating. So first thing we're going to do is look at the midline. So the first thing you do is the midline. I know it's the last thing on here, but it makes sense because you want to find your middle first. So what you're going to do is come here and find your high and find a low, and you're going to add them up and divide by 2. So my high is 23. I should put equal signs here instead of dashes so they don't look like negatives. 23, and my low is 7, and I'm going to divide it by 2. So that's 15. So my line y equals 15 is my midline. So what I'd like to have you do as soon as you find your midline is to put it there. I always do it dotted. And do y equals 15, label it, and look at it and say, yeah, that is the middle. I did a good job. Now once you have the midline, you can come up and do amplitude second. And when I do amplitude second, I know the amplitude is either high minus the midline, because you're looking for your vertical distance, or your midline minus your low. So if I take, and it's never negative, so I'm going to take my high, which is 23, and subtract my midline, so my amplitude is going to be 8. So that's the distance from here to here. Okay. My frequency, okay, I can't tell from here my frequency, so because my frequency is in the equation. So that's why I told you these two kind of switch. So if I have a graph, I'm going to do the period first and then the frequency. If I have an equation, I'm going to do the frequency first and then the period. So I look at it and say, how long did it take for me to see a whole curve? So I'm going to start here. If I follow it up, come all the way down, and I stop and say, okay, here's this, and then it repeats, okay, and then it repeats. So it took me that long to see it. So if I look at it and come down and say, oh, it took me is that 2.5 or 3? Oh, excuse me, I'm looking at the wrong thing. Sorry, let's erase that. It took me 3.5. So if I come down here and look at this, it took me 3.5 to see that. So my period is 3.5. And I know the formula is 2 pi over my frequency. So if I do that, and if I cross multiply, then I can figure out what my frequency is. So I cross multiply, put that over 1, so I have 3.5 times my frequency equals 2 pi. So then I keep going, and so I said my frequency is 2 pi over 3.5, or you can say 4 pi over 7. So my frequency is 4 pi over 7. The other thing I want to show you too is if your period does not have pi in it, your frequency will. And vice versa. If your frequency had pi in it, this won't. Okay? Now we actually can come up with a formula, and I'm going to tell you right now, sine starts at midline, and we're going to practice this later, but if sine starts at midline, cosine starts high, and I'm talking high on the y-axis. So this equation is y equals, and in front of the sine, I put my amplitude, so it's 8 sine. And in my frequency part, because the frequency comes here, is 4 pi over 7. And this was an x because that's our variable. And my midline is 15. So by doing that, we came up with the actual equation of that graph. And this year you'll notice that I'm shifting up and down and moving things. So it's not going to be like it was last year where they were always on at the origin. Okay, so let's look at another thing. We're going to determine amplitude, frequency, period, and midline for all of these. So we're going to stack and rack amplitude, and I'll let you write it like this. Amp equals frec for frequency, period, and midline. Please do not do AFPM. Just, I don't care if you shorten it, but that's good enough. Put equal signs there. And we're going to do it for here. Amplitude, frequency, period, and midline. Oops. So first thing we do is midline. So I have to do high plus my low divided by 2. So that's 1.5. You need to show me the work. Plus 0.5 all divided by 2. So that's going to be 1. So my midline is y equals 1. So I'm going to go through and draw my line y equals 1. And that does look halfway. Then we come up and do amplitude. So here's 1. Come up and do amplitude. And that is my high minus my midline. Or midline minus my low, and I get a 0.5. Because this is a graph, I do my period first, and then I do my frequency. So sometimes it switches, but it's always 1, 2, and then depends on what you have here. So my period is, I got to figure out how long it takes me to see it. Now I want you to start right here at the y-axis and say, okay, it starts here, comes down to here, and then it repeats. So that's how long it takes me to see it. Come down, say, okay, it took me 4. So that's my period. That's how long it took me to see that entire curve, which equals 2 pi over my frequency. Now if I cross multiply, I have 4f equals 2 pi. My frequency is 2 pi over 4 or pi over 2. Now after you get doing this a lot, you'll notice that if 4 equals 2 pi over my frequency, really what you're doing is, see what happens? The 4, you're basically flip-flopping their places. So I just usually flip-flop it right off the bat. You'll get used to doing this. So my frequency is pi over 2. So if I was going to do this equation, it'd be y equals, okay, this looks like cosine because it starts high. Amplitude comes first, so I have 0.5 cosine. Frequency comes next, pi over 2 x, and then my midline, plus 1. All right? The next thing we have is another curve here. So this one is a little bit different, and we're going to start right here. You always look here at the y-axis, and I'm going to do my midline first. So the high of this is 5. The low is -5, so that comes out to be 0, or y equals 0. Divide that by 2. So y equals 0 is halfway. That makes sense to me, so I'm going to draw the line. Amplitude's the next thing I do. I take the high minus my midline, or 5. I have a graph again, so I'm going to do my period first. How long does it take me to see this entire curve? So I see it starts here, and then it's going to, looks like it's going to repeat. So it looks like it takes me 4 to see this whole graph, so that equals 2 pi over my frequency. Flip their places, that's 2 pi over 4, or pi over 2 is my frequency. So if I was going to do the equation of this one's a little bit tricky because sine starts at midline, but it usually goes up and comes down, and this one is going down first then up, so it's been inverted. So even though the amplitude is positive, we have to stick a negative in front just because this has been inverted. So the negative means it's been inverted. This is an inverted graph. It went down first instead of up. And it's going to be inverted sine. So it's sine, and then I put pi over 2x, and I could put plus 0, but I don't need to. Okay, so that's a little bit of basics of trig introduction, and that's it.